Hello Spark fans and welcome back to Advancing Spark, where it's been a whole week since I did a video. I know, but my internet broke and I was really busy. So what are you going to do? And what happens if I just be here for a whole week? Well, Databricks go and release yet another runtime with a load more functionality in it. And on the surface, it doesn't look like there's that much in there. There's only 3 new features, 2 of which are operational logs. But the one that is in there is a bit of a biggie. So it's going to take a little while to run through the entirety of the new schema drift functionality in Autoloader. And I know you might be thinking, wait, didn't we do that last time with the unparsed data JSON thing? And yes, a little. This is new, bigger, better, and has a whole ton of stuff in there. Loads of new options, loads of new complexity, and we'll take a look at everything that's in there. As always, do not forget to like and subscribe. Hello, if you're new to the channel, do stick around. We do lots of this kind of stuff. And as always, let me know in the comments if you've tried it out, if you think it's useful, if you can go, oh my God, that fixes a problem I've always had. Let me know. Cool. Let's have a look at some stuff. So firstly, we've got the normal runtime overview, we've got the release notes, and the 3 headlines that we've got. So the new Autoloader Schema Evolution options, that's what we'll go into. Loads and loads of stuff in there. Vacuum metrics and cloning metrics. So again, just more good stuff. Whenever we do an action, whenever we do a merge, an update, an append, whenever we delete data, whenever we clone data, restore data, or vacuum data in our Delta table, we want those logs. We want the operational details. How many files did I touch? How many things did I move? How many folders got updated by this? We want that in our transaction log so that when we look at the history of that table, we've got that good operational detail. So these 2 are essentially just doing that. So you get that good, nice operational stats coming out saying, this is how many files the vacuum affected. This is how many things my clone actually affected when we're doing it. How big was it? How much did I copy over? How many individual files did I copy over? All that nice good stuff just goes into the transaction log, and then we can query it and we can use it and we can go and do stuff with it. It's just that as an output saying when it's finished, this is what I finished doing. Just super useful. So they're really, really, really good. And then there's the normal stuff of all the different bugs. It's worth looking through all the different fixes that have gone in. The usual Spark bug fixes, usual upgrades to a load of different libraries. But the main thing we're looking at is this whole beast of a thing. So Autoloader, we've done videos about Autoloader before. I'll put a link to a previous Autoloader video up. And that is essentially this file watcher that will sit there constantly trying to stream from a folder. And if you drop new files in there, it'll stream them through automatically. But obviously, if the schema changes, it's not very good at dealing with it. And we've had a look at this thing called unparsed data in previous videos. And that's where we're taking it and we're just kind of saying, well, those columns that don't make any sense, just dump them in there. Just put them over there. Put them out of the way. And one of the struggles with Autoloader is that you had to give it a schema. So even if you wanted to give it a schema and then bundle in anything unexpected into this unparsed data column, I still had to give it a schema. Even if I'm dealing with like Parquet files, which have a schema inside it, I still have to give it a schema. So some of the big things in here is all to do with, you know what? I want to infer the schema on the fly. And that has its own set of challenges. So we'll talk about schema inference. We'll talk about this thing. So now when we're looking at an Autoloader query, an instance of Autoloader, it basically needs somewhere where it can go and keep its own record of the schema. So when we spin it up, when we say, no, I'm not giving you a schema, you work your schema out yourself, it'll go and infer the schema, figure out what it looks like, and then save that down as metadata. So next time it starts, it's just going to go and use that metadata. Essentially, it's got its own metadata store. It's going to keep a file somewhere that describes the structure once it's inferred it for the first time. That's cool. We've got some configs. We can decide how it does that. We'll step through that in a bit. We can apply this to other data types, not just JSON. Again, super, super useful. And we've got this idea, rescued data, which is exactly the same as unparsed data was. They've just called it rescued data now. Yep, cool. We can do things called schema hints. So if we're no longer supplying a schema to our Autoloader data frame, we're saying, no, you figure it out. But by the way, that should be a long, not an int. We can give that kind of recommendation. So we can pass something. It's not strict. It's not saying this is definitely what I expect it to be. It's saying, if you come across this field, this is the data type you should use. And it's kind of like just allowing us to steer and guide it. And that doesn't have to be the full set of the schema. I can give just a subset of columns of the ones that I want to impact, and any other columns it finds, it will include in its actual schema. I can just give hints for the ones that I particularly care about. So super useful. Weird idea, and you don't pass it in. You pass it as basically a comma-separated list, kind of SQL style of column name, data type, comma name, column name, data type. So you're not passing it in as a Spark struct, and that's a little bit weird, but we can impact how things are working with that. And then we have these things. We've got these new ways of telling it how to deal with changing data. Should it fail? Should it break entirely? Should it update its own inbuilt schema so that the next time it starts, it will actually have these new columns, have these changes to the schema built in, and it's going to expect the new schema? Or should it use that rescue column? And so we can keep a fixed one from the very start. Whatever we start with, that's our structure. And then we'll have this rescue column with other stuff going in. And we can use a bit of mix and match, and we've got different ways of working in it. So loads of different things we can do inside there. So yeah, lots of stuff. But let's go and have a look at how it works. So I'm going to use the same demo I did when I was talking with unparsed data. So I had this, I've got some JSON knocking around. Let me just get that up for you so you know what that looks like. So we're going to talk about, let's grab this. I'm going to say we've got this. So we've got a real basic little JSON data set, product ID, name, color, list price. And then we've got an updated version. So we've got size and weight added in there. And then we've got an even more updated version, which has got a load of extra stuff, and it's got all of the AdventureWorksy goodness. It's got a whole binary thumbnails. It's got lots and lots of different things in there. So we have this kind of like expanding data set that's evolving over time. We have Schema Evolution as a bit of a demo. So we've got that. That is sitting in a little landing area. So I've got a blob store, got my product lists in here, and I've got my original. So I've got my super simple data set, not much going on in there, just my really basic little bit of JSON. And that's our starting point, right? So we've got that one file in there, and we'll see how it goes. I've then got a place I'm going to be looking at the schema. I'm going to be tracking the schema over here, and we'll see what that looks like and see how that builds up over time. So on my notebook, I've got my 8.2 beta cluster, and we've got a few things in here. So let's have a look. Firstly, setting a bit of config. So when I'm doing my cloud files, aka Autoloader, I don't know why they call it cloud files and Autoloader and just call it one thing. But essentially, whenever I'm doing schema inference through Autoloader, should I have how much data, so what's the actual physical size of data I should try and read, or how many files should I try and read? So just going to saying, if you've got loads and loads of those, just go and just read 10 files, read 1 file, read 3 files, whatever makes sense for your data sizes. We can set that as a cluster config size. Now, in the original demo, I had to supply the schema. So I had this contrived JSON schema that was saying, this is how to go and read my product list. I had to give that into Autoloader before Autoloader would work. I don't need that anymore. So I've commented all that. I just included it so you can see what that used to look like. We no longer have to provide that into our mix. I'm then going to get a load of secrets, get all that stuff sorted, and then building up my cloud file config. And there's more and more options added in here. So this stuff is all the usual stuff. That is telling it what format of data. So I'm reading JSON. I'm telling it how to do a service principal because I'm using the file notification. So it's doing the whole event grid queue. It's keeping a log of all the different files coming in. It's all the fancy cool stuff. And then I've got the new options down here. So I've got infer columns types turned off currently. And we'll have a look at what that actually does, what that means. I've got my schema location. So I've given it a location because this is Autoloader 3 Tokyo Drift. And this is where it's going to go and manage that schema drift as it goes. And it's going. One of the recommendations is actually, if you're using Autoloader into a given Delta table, and you've got to manage a checkpoint for that streaming anyway, you might as well keep the schema objects inside that checkpoint. It kind of makes sense to bundle it all together, unless you have several streams writing to the same table. And that's not going to work. So be a little bit careful about what you're doing, but yeah, managing that schema kind of makes sense to put it in that same checkpoint. Partition columns we'll come on to. I've not got the partitions working in this demo, But essentially, if you wanted to read the file structure and go, oh, hey, actually in here, not in my schema location, but wherever I was loading data from, if that had something built in that was Hive style, so it's like year equals 2021 and my month equals 2002, I know what months are. Then if we supply that list of year, comma, month, it'll understand that and it'll include those automatically in the inferred schema. So we can get it to do that kind of thing. I don't know why it doesn't just treat partition columns the same way any other data reader does, but it doesn't. So, we can do that if we want to. And then we've got a Schema Evolution mode. So what should happen when it's doing it? For now, we're going to switch it over and have it in rescue mode. Okay, so I'm not going to infer types. I'm going to store my schema location there, and I'm going to have my Schema Evolution mode as rescue. And we'll have a look at what that does. We then got some additional things that we can do. I've got the schema hints turned off for now, and we'll go back to that in a second. And I'm telling it, if you are rescuing data, put it into that rescue data column. Telling it how to connect to the blob. Finally configuring my data frame. And you can see, so that has gone through and just inferred the data. I'm not passing in the schema. I'm not passing in schema hints, not giving any data. I'm just saying, just go auto load from that location, please. And it has worked out the structure, which is not that shocking. It should be able to do that, right? Now, because I've done that, and because I had a schema location, it will have gone and worked that out. So it's got a load of strings. By default, it is inferred everything as strings. And I can go and have a look in my location. I've now got that checkbox folder. I've got my schemas, and I can see it's created a schema file for me. So have a looking inside there. What's in that schema file? It's just a JSON data frame struct. So I can see all in there. It's got color, it's got the list price, it's got all the stuff I would expect to see inside any other Spark structure, schema struct, those things. So I can go and use that. And it's also got the partitioning information at the end if I had any, which I don't here. So it's going and keeping that metadata for me, which is interesting. So let's do some more stuff. If I go back and actually say, you know what? That's not what I want to do. I want to, by the way, product ID should be an int. My list price should be a decimal. I want you to use those for me. Now, if I try and use it immediately, I reckon it's not going to do anything. It's going to ignore my hints. Oh, no, it is. Oh, okay. So in this case, my hints have overridden my baked in schema. So despite the fact that the schema sitting over here is actually stored thinking everything is a flat string, because I've passed in a hint, is overridden that in terms of what it's done. So you've got that level of precedence. You've got the known schema, then the schema hints I'm passing in as to how it should understand that. Which is interesting. And then we can switch it around. This time, let's say I want you to infer the column types. And in this case, rather than just assuming everything's a string, or everything's a string unless I've told you a hint otherwise, it's going to use the built-in Spark schema inference. So it's going to go in there, going to read it out. It's going to go and not do anything at this point because I've got my fixed schema. If I go and delete my fixed schema and say, get rid of that, you no longer have a stored schema, go and infer it from scratch. Then when I run this again, it'll do the inference and it's worked out slightly differently. I actually came up with the same answers, but you've got that whole idea of, are you going from the baked in fixed thing with hints? Or are you going from the actual live inference? Let me just undo that. Let's go back to not having schema hints in there. Let's again delete that schemas and say, forget what you just did. And we should now be able to step through, run that again, see what that comes up with. So this time it came up with a double along. So that's actually using schema inference. That's how it would interpret those two different data types. If I gave a schema hint, it overrides it. So there's two different things. Do you want it to work it out for you? Do you want to assume everything's a string? Do you want to pass in some hints and guide it on the right direction to picking the right data types? You've got those options by either using that infer column types or using the schema hints as an option that you pass in. Both work, both make a lot of sense. Okay, so doing that, we can just read some data, go and have a look at what our data looks like. And we should just see a few files that all kind of make sense. Nothing particularly crazy in there. Thinking about it, awfully slow starting a stream, so we can go and read 10 records. And then we'll see what's in our first file. And again, shouldn't be anything particularly crazy in there. There we go. So we've got our data as it is, and we've got this rescued data, but nothing's in there. Nothing's had to be rescued because everything matches the schema it's expecting. And because Autoloader is a streaming thing, it's going to just keep streaming that it's turned on. I've not got any trigger once or anything like that going. So what we can do is we can hop over here. I can upload a new file. I'm going to grab that product list 2020, hit upload. So that's added it. And because Autoloader is constantly looking at that, I should be able to hop over here. And then next time this refreshes, we'll see those new rows added. Now, because up here, I've got my Schema Evolution mode in rescue. So it's not going to change the schema. It's not going to reevaluate what's held in that schema metadata. It's going to do the same as we saw with that unparsed data. It's going to dump anything it doesn't recognize. It's going to dump it into that rescued data column. And again, this is a nice evolution from where we were with that unparsed data. Because that was unparsed data against the schema that I had to provide. I had to hard code, give it a schema, say this is what you're expecting. Now we've gotten rid of that step. We can just say, go read some data. Figure out what it looks like when you first start the stream. And if later anything comes in once that stream's been running for a while that doesn't match that initial schema, just dump it in rescued data. It'll be fine. Don't worry about it. So that's quite a nice pattern. It's quite nice and easy to set up and work with. So we go and have a look at the schemas that we have. We still only got one schema file. And that schema file, so we see what's in here, what we've got. Color, we've got list price, we've got name, and we've got product ID. So we don't have size and weight. We don't have those two additional columns haven't been updated to the schema. My schema is fixed, and I'm just handling everything that doesn't fit that fixed schema inside that rescued data. So let's change that. Let's go, no, I don't want you to just rescue things. I want you to add new columns. I want you to go and update that schema and actually include the new data as I go. So we go through, we'll do this again. So this time it's gonna infer the schema. Oh, no, it's not. Okay, so this, because I already had a schema file, it's gone and recognized I've already got a fixed schema. So it's like, yeah, cool, I know what it looks like. It hasn't gone back and re-inferred the schema looking at the new file that's in there. So it's gonna try and run, and it's gonna try and apply that existing schema to the new data sets that I've got there, and it's gonna fail. It's gonna say, no, it doesn't work. You've got size and weight in some of these things. That doesn't make any sense. So there we go. So we've got an unknown field exception. So it uncounted unknown fields, weight and size. So that has deliberately failed my stream. Now, for me, that's why the add new columns it's slightly misleading in what it means. What it actually says is, upon finding any new columns, fail the job, update the schema so it includes the new ones, and then when someone restarts the job, you'll have those new columns in your structure. So actually, if we just take a step up and we go, start it again, we can see we've got that updated structure. So we can then go and just rerun this thing. So we've not changed anything. We've not had to go and update a schema. We've not gone and fixed anything. It just automatically fails, updates the record, and then when you restart, it'll have the new structure in there. And that's because it's a streaming job. It's expecting the good practice architecture when you're doing Databricks streaming is to have this in a job that has automatic retries. So you leave the job just streaming and running, and if it ever fails, it just retries and carries on from where it left off. And that's kind of the plan here. So it failed, it updated its schema record, and then as soon as you restart, it can just restart quite naturally with the new structure. So if we go and have a look in our schema file, we'll see it's got an evolved structure. So it's got an updated its own metadata. It's added in that new file. So we can now see, knocking around in here, we should see weights and size on now part of our structure. So that kind of whole setting of, again, add new columns is fail, update schema, add new columns is actually what it's going to do. Now we do have the other option of just fail on new columns. And that's I don't want you to update the schema for me. I want you to break so I can go and update the schema myself. So it's whether or not it should manually update the schema is the setting that we've got there. But that's quite nice. That kind of add new columns, update the schema, manage it yourself, and go and work it out. So some quite nice things in there, but it feels slightly daunting when you first look at it. And you've got this idea of schema hints versus the schema metadata system that can be held in the checkpoints, and it's got auto restarts, and all of that kind of stuff feels a little bit intimidating when you first open it up. But actually, all it's doing is what many of us are doing in our own metadata systems. It's keeping the metadata as JSON for what it expects the structure to be, and then expects you to restart upon any change and just carry gracefully on from there. Pretty cool. So I think that is all of the bits that made sense to run through. So we've got our rescue data. And again, rescue data is only going to be used if we're in that rescue mode, not the add new columns mode. Schema Evolution is now baked into it. And we can use schema hints if we want to just nudge the schema inference into picking the right types. Maybe the initial data set isn't representative. We know there's going to be bigger numbers coming through. Don't try and make it an int. It should be a long, bigger int. And all that kind of stuff is now baked into it. So yeah, loads and loads and loads of stuff in there for a little, we just added Schema Evolution into Autoloader. And it is, again, if you're already using schemas baked into things and you're already using the unparsed data column, it's not that massive a shift. If you already like that idea of saying, this is my fixed part of my structure, this is my flexible, evolvable part of my structure that I can go and have drifting, essentially. As new things come in, just handle it there so I don't have to update my structure, and I can just let people go and dig into it with the new JSON querying objects that came in last release in 8.1. Just loads of really nice ways of working with that. So really, really good ideas. Really nice to see. It's a little bit weird for me because most of the time I use Autoloader, I use it in trigger once mode. So I'm still doing batch processing. I just trigger Autoloader to work out what have I not processed yet, and then process all of that through. So the fact that I'm doing that, and if that fails, I've got to restart it to deal with Schema Evolution. It's going to be a slightly weird pattern to get used to. But from a full Autoloader streaming point of view, something new comes in, stop the stream, automatically restart the stream. It's now got the updated Schema Evolution, and I've got my track. I've got a folder which has got the evolved structure as everything's come in, as it's had to change and flex the schema to go with what's going on. It's actually a really nice audit history of what's gone on with that particular Autoloader stream. So really interesting in 8.2, lots of interesting stuff. Again, metrics, I love metrics, more metrics, really, really happy to see lots of metrics coming in. But the Schema Evolution, if you are using Autoloader, is really, really interesting. Now, it's always been a bit of a toss-up as to Autoloader has a load, it simplifies a ton of stuff in terms of having to figure out which files have I read, what have I not read, what came in since I last did the batch. All of that kind of stuff just gets wrapped into that complexity, which is awesome. But then everything has to be a stream. And if I want to do like merging into a delta table, I've got to do the for each batch stuff. And it adds complexity in other places whilst removing it in other places. And it's like, it's a balancing act of, are you going to use the really nice features, and does it outweigh the complexity of doing some of the traditional batch loading stuff? And that's been a bit of a seesaw as to, does it actually outweigh? And the more they're adding this stuff in, the more we're seeing its ability to evolve and deal with Schema Evolution and deal with some of the real challenging problems of doing modern ETL with semi-structured data like JSON. It's just a much, much bigger argument to start using it and start plugging it in as a standard way of loading. So super, super interesting to see. Apologies, that was a bit of a rant. But yeah, let me know what you think. Let us know if that's something you think you're going to use. Let me know if you've got other ways of dealing with Schema Evolution and Schema Inference, and you don't need that stuff. Really interesting to see how other people are tackling that challenge. As always, do not forget to like and subscribe, and we'll see you again soon. Cheers.